All right, good morning or good afternoon, whenever you're starting. We're looking at day 6, horizontal asymptote. So this is kind of like the last big picture of rational functions. So we're gonna, we've looked at vertical asymptotes and I've mentioned horizontal asymptotes, but now we're gonna officially look to see how to find them and what they are. So the first things first is you are going to plug in this function into your calculator. F of x divided by g of x. Okay, so it's going to be x minus 5 divided by x squared minus 6x plus 8. And you're going to look at your outputs when x is 0, 100, 200, 300, and so forth, and then as well as in the negatives. And remember how you can put this into your table, so you can just enter them in instead of scrolling. Remember, if you hit second window, which is your table set, make sure your independent variable, and we've done this in class, so this should not be anything new, but your independent variable needs to be highlighted on the ask. Again, the way to get in there is hit second window, which is your table set. And then when you go to your table, you can type those in. Okay, so go ahead and pause the video and fill in your tables. Okay, so these should be your table values. And so what it's asking us to do, it says as the x values move away from 0 in the positive direction. So if you're picturing your x-axis and your y-axis, this first part right here is asking us to pay attention to what are our y values approaching as x gets bigger. So notice x goes from 0 to 1,000. So we are way out here. What are our output values? They're getting closer and closer to 0. So what we should be noticing there is that these, our outputs, our y values, are just getting closer and closer to 0. And then in the negative direction, so now if we look over here, so that's what's being asked over here, as it moves away from 0 but towards negative infinity, what's happening to our values as we get farther and farther away? Notice you start at negative 0.625, and then you're at negative 0.009, so which is really negative 0.01. But by the time you get out to negative 1,000, you're at 0.001. So it's also getting closer and closer to 0. Okay. I want you to go ahead and do number 2. Go ahead and look at your table of values and answer those same questions. And make sure you look at your graph to compare your answers to what you get to see if that's actually what's happening. So you should get, for these, notice as x gets really big here, your y value is getting closer and closer to, hopefully you recognize this, it's getting closer to the number 2. And here, as x gets really small in the negative direction, it's also getting closer and closer to 2. So notice all of these values over here are getting closer to 2, but values that are greater than 2. And then over here, they are getting closer to 2, but they're all values a little bit less than 2, because that's going to be underneath that asymptote. So when you do go look at your graph, this graph is a little bit complicated in the middle, and it's just because it's busy. There's a lot of stuff going on. There's vertical asymptotes at 1 and negative 1. But your graph, it gets closer to 2 from above on the right, and it gets closer to 2 from below as it goes out, okay? And that's where that horizontal asymptote comes from. A horizontal asymptote, the graph can cross it. Why the horizontal asymptote is there, it's telling you what your function values are approaching as x gets really, really big towards positive infinity or really, really small towards negative infinity. Okay, when you look through the rest of the notes for today, pages 14 and 15, they are the exact same thing. Looking at your graph, looking at what's happening as x gets really big, as x gets really small. If you feel you need to practice and look at that and fill in the tables for 3 and 4, go for it. I'll fill it in here so you can Just check your answers if you want to. But otherwise, I'm going to say let's skip to number 5 just because it is a little bit different than what we saw in 1 and 2. So pause the video. I do want you to fill in your tables for number 5. And I want you to figure out what you think r of x is approaching as x goes to infinity and as x goes to negative infinity, okay? When you unpause it, 3, 4, and 5 will both be filled out, so I will show you both so you can pause it and check it and all that, okay? Okay, so the reason that I did want to for sure look at number 5 is notice that these numbers aren't getting closer to anything. They just keep, in this side where x gets bigger, these values just keep getting bigger and bigger and bigger. And if you look at the other side, as x goes to negative infinity, notice what's happening here with your y values. They just keep getting smaller and smaller or larger in the negative direction. So it says graph to confirm your answers. So what you're going to see when you look at your graph, you're going to see over here that it's approaching positive infinity, and down here it's approaching negative infinity. Okay, so those are, it is different, okay, and the reason is because we actually have what's called a slant asymptote instead of a horizontal asymptote. So all the ones we've done so far is we have this horizontal asymptote that the graph is getting closer and closer to as x gets really big or x gets really small. Well, now we're going to have what's called a slant asymptote, and a slant asymptote is just going to be like a dotted line like this, and it's just telling us, again, it's kind of taking that horizontal asymptote and putting it on a slant, okay? So here it says to divide. Notice that's our function from up above. Divide and write your answer as a linear equation, and we're going to disregard our remainder. So we can, remember, we can do this with long division or we can do this with synthetic. Since we're dividing by a linear function, set it up as synthetic because it's a lot faster. Bring down the 1, add those up, and this equals x minus 1 plus your remainder over x minus 2. But notice what it said, disregard the remainder. This actually is our slant asymptote of our graph. So if you go and look at your graph on your graphing calculator, the slant asymptote is this line right here, okay? They're not values on your graph. It's, again, slant asymptotes and horizontal asymptotes tell you what's happening at the ends as x goes to infinity, as x goes to negative infinity. So if you look at your graph on your calculator, first of all, we know we have a vertical asymptote. We've learned about this, right? That's not new for us here. And you can see that you have a curve up here and you have a curve right down here, okay? Again, the calculators typically don't graph that dotted line, so that's why it said to graph it along with it, because you'll see it. And it's just telling you, again, end behavior, okay? As x gets really big, 1,000, that means that we're out at 1,000 minus 1. Or if we're at 1 million minus 1. So it's just getting closer and closer and closer to positive infinity. And then as x gets really small, it's getting closer and closer to negative infinity. So that is your end behavior, okay? So this last sheet, the last page here, is putting this all together. And the summary of horizontal asymptotes, it equals, so if the degree of your numerator and denominator are equal. So notice in this first one that I'm squaring off in blue, it's a quadratic divided by a quadratic. Your horizontal asymptote, what it's going to equal is your ratio of your coefficient. So you just look at your 3x squared over 1x squared. If you divide that, what does it equal? 3. Go back and look at this graph. You're going to see as x gets really small, the function goes to 3, and as x gets really large, the function is going to go to 3. Now notice in the next one, it says the degree of f of x is less than g of x. So we don't have an x squared in the numerator. What we can do is we can add in an x squared, okay? And we can do that without changing the function by adding in a 0x squared. So think about this as the same as the above problem. What's 0x squared divided by x squared? 0 divided by anything is 0, right? So as x gets really big, it's going to approach 0. As x gets really small, it's going to approach 0. Again, end behavior. That's what this is telling us. And then the degree of f of x, if the numerator is greater than, the reason you actually have a slant asymptote. So if we kind of do the same thing we did in that last one, since it's x squared divided by a linear, we can add in a 0x squared without changing the problem, right? So whatever that simplifies down to, that is your horizontal asymptote, just like it was in the red one and in the blue one. Well, here we can't divide by 0, so therefore there isn't a horizontal asymptote, and that's when the slant asymptote happens. Okay? Now, you might be looking over here and thinking, what is all this notation? All this is asking you for, you're actually doing a little bit of calculus right now. What this reads over here, so if we look at the one in blue, it says what this is stating is the limit as x approaches infinity. That means as x gets really big, this function is getting closer and closer to 3. This over here, as x gets closer and closer to negative infinity of this function, our y value gets closer and closer to 3. All that is, you guys, is end behavior. I'm not going to ask you to write that, but I just want you to realize, like, why we're looking at this and where this is taking us, and this is a big part. So if you do end up taking calculus, whether it's in high school or in college, this is going to be one of the first things you talk about, and all it really means is end behavior. As x approaches infinity, in this case, r of x approaches 3. As x approaches negative infinity, r of x approaches 3, okay? So with these bottom ones, these are all worked out for you. Or no, the first one's worked out for you. I'm sorry. It says determine the horizontal asymptote for each graph. I'm just letting you know, I'm not going to ask you to find the slant asymptote like we did in this question over here. Okay, so don't stress over that. I'm just going to ask you, what is the horizontal asymptote? And if there isn't one, you're going to say none, okay? So best thing to do, and you can do this with all your problems before you even get started, is go look at your powers. So if we look at number 8, you have a quadratic divided by a quadratic, okay? Your horizontal asymptote is whatever you're left with when you divide those two. Look over at 9. We don't have a quadratic, so you got to add it. How do you add it without changing the problem? It's a 0. Over here, you got to add it. How do you add it without changing the problem? It's a 0. So going back to question 8, what's 3x squared divided by 1x squared? It's 3. So your horizontal asymptote is y equals 3. If we look at our graph, what that means is now when we graph our rational functions, you're going to put that line in there as well. You didn't always see it with the graphs, kind of depending on the ones that we've done. If they were, if it was the line y equals 3, y equals 1. But if it was just the x-axis, you may not have realized that was what was happening, okay? And that's okay. So that's why we're kind of putting this last thing together here. Question 9, what do we get when we do 0x squared divided by 1x squared? 0 divided by 1 is 0. So that's, again, your end behavior. What's happening as x gets really big or x gets really small? Here, x squared divided by 0x squared, we can't divide by 0, so there isn't a horizontal asymptote, okay? There's just a slant. Go ahead and answer 11 and 12, hit pause, and then check back to make sure you got it. So for both of these, you did need to add in the 0x squareds. For 11, you're doing 1 divided by 0, which you can't do, so there's no horizontal asymptote, there's just a slant. And in 12, it's 0 divided by, or 0x squared divided by 1x squared, which is y equals 0. So as x gets really big, this function's going to approach the x-axis. As x gets really small, it'll also approach the x-axis. And you can confirm all of your answers on your graphs or looking at really large numbers on your table.